Uh, Welcome and good evening, ladies and gentlemen. Yesterday I uploaded a video on binary logistic regression models, and today one of my PhD students, Mr. Mahfouz Khan, he was delivering a seminar on his PhD dissertation, and he also used multinomial regression models in his PhD thesis research, in addition to some other regression models. There were some problems relating to interpretation of the multinomial logistic regression models in his presentation. So I thought I should better upload a video on multinomial logistic regression models with some hypothetical data, and I will interpret some of its theory, and I will interpret the results of the multinomial logistic regression model. So my dear students and colleagues, I hope you would like this video. Kindly be with me and follow me attentively. So let me start with the introduction of the multinomial logistic regression model. Multinomial logistic regression is a simple extension of the binary logistic regression models, which allows for more than two categories of the dependent or outcome variable. That is, in the binary logistic regression model, we have two categories, whereas in the case of multinomial logistic regression models, the outcome variable has more than two categories, and it is called polychromatous as against dichromatous in case of the binary logistic regression model. Like binary logistic regression, multinomial logistic regression uses maximum likelihood estimation to evaluate the probability of categorical membership. Multinomial logistic regression is used to predict categorical placement in or the probability of category membership in on a dependent variable based on multiple independent variables. The independent variables can either be dichotomous like binary, or continuous, that is interval or in ratio scale. A multinomial logistic regression is often considered an attractive analysis because it does not assume normality, linearity, or homoscedasticity. A more powerful alternative to multinomial logistic regression is discriminant function analysis, but that requires these assumptions are met. So indeed, multinomial logistic regression is used more frequently than discriminant function analysis because the analysis does not have such assumptions. Multinomial logistic regression does have some assumptions, such as assumption of independence among the dependent variable choices. Now what does this mean? This means that this assumption states that the choice of or membership in one category is not related to the choice or membership of another category, that is the dependent variable. The assumption of independence can be tested with a test called Hausman-McFadden test. Furthermore, multinomial logistic regression also assumes non-perfect separation. If the groups of the outcome variable are perfectly separated by the predictors, then unrealistic coefficients will be estimated and effect sizes will be greatly exaggerated. Don't worry about the complicated theory of multinomial logistic regression model. Just try to understand how this model is run in SPSS, and how we interpret the results. Here I give an example of hypothetical data, and this data I downloaded from the internet. The data is available online, and let us suppose that this data relate to 200 economic students in Institute of Development Studies. The dependent variable used in this analysis is students' favorite flavor of ice cream, and these three flavors include chocolate, vanilla, and strawberry. So the dependent variable in today's analysis is polycarbonate, and we have coded chocolate as 1, vanilla as 2, and strawberry as 3. There are two independent numerical variables, and these include various tests on a video game and puzzle. So video and puzzle are two independent numerical variables used in this analysis. In addition to two numerical independent variables, we also have included one categorical independent variable in this model, and that is gender. And here female is coded as 1 and male is coded as 0. The outcome measure in this analysis is the students' favor of ice cream, from which we are going to see what relationships exist with video game scores, puzzle score, and gender of the subject. This is the output of the multinomial regression model. I later on show how to do that, but first I would like to explain and interpret the main results of the multinomial regression models. In the upper diagram, in the upper table, you see that there are three flavor of chocolate, of ice cream. Chocolate is coded as 1, vanilla is coded as 2, strawberry is coded as 3, and these are the frequencies of the students' preference for various flavors. 47 of the total 200 students preferred chocolate. 95 students out of 200 preferred vanilla, and 58% of the 200 students favored or preferred strawberry. So here are the percentages. 23.5% of the students preferred or chose chocolate. 47.5% of the students choice was vanilla, and 29% of the students chose strawberry. So we can say that vanilla is the most frequently preferred ice cream flavor and will be the reference group in this example. In the data, vanilla is represented by the code 2, chocolate as 1 and strawberry as 3, and we will use multinomial regression in this model. So here in this case processing summary, again these are the frequencies of the 3 chocolates. This is the total number of the students or the participants which are included in this analysis. And here you see there is subpopulation, and the number is 143. And here in the footnote, the SPSS has written that the dependent variable has only one value observed in 117 or 81.8% subpopulation. I'll interpret this. I'll discuss this. This is the model fitting information, and there are lag likelihood and chi-square statistics and the significance. These are the pseudo R squared. The Cox and Snell R squared is 0.153. The Nigal Karke pseudo R squared is equal to 0.174, and the McFadden R squared is equal to 0.079. And these are the parameter estimates of the model. Now this is chocolate versus vanilla, because vanilla is used as a reference category, and this is strawberry relative to vanilla. So I am going to explain all these results. Let me start with the case processing summary. Here you see there is capital N, and the subscript is B, so the explanation is here. Now N provides the number of observations fitting the description in the first column. For example, the first 3 values give the number of observations for which the subject's preferred flavor of ice cream is chocolate, vanilla, or strawberry respectively. So these are the three values. One is 47, one is 59, one is 58, and these are the percentages: 23.5%, 47.5%, and 29.0%. So these are also called marginal percentages. And here you see the word ice cream. Now, ice cream in this regression is the outcome variable, which contains a numerical code for the subject's favorite flavor of ice cream. The data includes three levels of ice cream representing three different preferred flavors: one for chocolate, two for vanilla, and three for strawberry. And as I told you, this is the total. Here, total means the total number of subjects or the total number of students. Now I'm going to explain this subpopulation. Subpopulation here indicates the number of subpopulations contained in the data. A subpopulation of the data consists of one combination of the predictor variables specified for the model. For example, all records were female is equal to 0, video score is equal to 42, and puzzle score is equal to 26 would be considered one subpopulation of the data. The footnote SPSS provides indicates how many of these subpopulations of the predictor variables consist of records that all have the same value in the outcome variable. In this case, there are 143 combinations of female, video, and puzzle that appear in the data, and 117 of these combinations are composed of records with the same preferred flavor of ice cream. Below, there is model fitting information, and here in the model it indicates the parameters of the model for which the model fit is calculated. One is intercept only, this is intercept only, and one is final model. So intercept only describes a model that does not control for any predictor variables, and it simply fits in intercept to predict the outcome variable. Final describes a model that includes the specified predictor variable and has been arrived at through an iterative process that maximizes the log likelihood of the outcomes seen in the outcome variable. By including predictor variables and maximizing the log likelihood of the outcomes seen in the data, the final model should improve upon the intercept only model. And this can be seen in the difference in the -2 log likelihood values associated in the model. Now let me discuss the log likelihood, -2 log likelihood. This is the product of -2 and the log likelihoods of the null model and the fitted final model. The null model means intercept only model, and the final model means in which we include all the predictor variables. Now the log likelihood of the model is used to test whether all predictors regression coefficients in the model are simultaneously 0, and in tests of nested models, there is also a chi-square test, and this is the likelihood ratio chi-square test that at least one of the predictors regression coefficient is not equal to 0 in the model. The log likelihood chi-square statistic can be calculated by -2 times null model minus into -2 times fitted model, and that is equal to 365.736 minus 332.641. So the chi-square statistic value is equal to 33.095, where log likelihood null model is from the log likelihood with just the response variable in the model intercept only, and the log likelihood fitted model is the log likelihood from the final iteration, assuming the model converge with all the parameters. DF means DF stands for degrees of freedom. You are familiar with that. And SIG in the SPSS output stands for probability value, and below there are the pseudo R-square. I already explained these. The first one is Cox and Snell pseudo R-squared. The second one is Nagel-Karke pseudo R-squared, and the third one is McFadden pseudo r squared. Now there are three pseudo r squared, as I told you. Logistic regression does not have an equivalent of the r squared that is found in OLS regression. However, many people have tried to come up with one. There are a wide variety of pseudo r squared statistics which can give contradictory conclusions. Because these statistics do not mean what r squared means in OLS regression, we suggest interpreting with great caution. So here are the parameters estimate, and in this model you see in this column there is B. Now B, these are the coefficients. This is the coefficient of the intercept, this is the coefficient of the video, this is the intercept of the puzzle, and this is the intercept of the gender, and this is for chocolate relative to vanilla. Similarly, these are coefficients for strawberry relative to vanilla, and the reference group category is vanilla, which is coded as 2. Now let me interpret the results, and first I would like to interpret chocolate relative to vanilla, because vanilla is the base category. So here is the intercept, and this is the intercept is a 1.912. This is the multinomial logit estimate for chocolate relative to vanilla when the predicted variables in the model are evaluated at 0. For males with 0 video and puzzle scores, the logit for preferring chocolate to vanilla is 1.912. Now we must note that evaluating video and puzzles at 0 is out of the range of plausible scores, and if the scores were mean centered, the intercept would have a natural interpretation, log odds of preferring chocolate to vanilla for a male with average video and puzzle scores. Now I come to the intercept of the video, which is minus 0.024. This is the multinomial logit estimate for a 1 unit increase in video score for chocolate relative to vanilla, given the other variables in the model are held constant. If a variable were to if a subject were to increase his video score by 1 point, the multinomial log odds of preferred chocolate to vanilla would be expected to decrease by 0.02 unit while holding all other variables in the model constant. Remember, ladies and gentlemen, we must look at these exponentiated beta. If the value of exponentiated beta is greater than 1, then the sign of the coefficient will be positive. Like here, it is 2. So here the sign is positive for the gender. But in these two cases, for video and puzzle, the value of exponentiated beta is less than 1. So the sign of the video and that of puzzle are negative. Similarly, in the case for strawberry relative to vanilla, the exponentiated beta for video and puzzle are greater than 1. So the sign of the coefficients are positive, and we can interpret these coefficients the way I described for video in case of chocolate relative to strawberry. Now coming to puzzle, the coefficient of the puzzle, that is the multinomial logit estimate for a 1 unit increase in puzzle score for chocolate relative to vanilla, given the other variables in the model are held constant. If a subject were to increase his puzzle score by 1 point, the multinomial log odds of preferring chocolate to vanilla would be expected to decrease by 0.039 unit while holding all other variables in the model. Ladies and gentlemen, I am not going to read each and every word and sentence in this. I leave this for you. You can read this. There is a full interpretation of these results. And now I would like to come to some other variables like Wald statistics. And here is chocolate relative to vanilla. Now for chocolate relative to vanilla, the Wald test statistic for the predictor video is 1.262 with an associated p-value of 0.261. Now what does this mean? It means If we set our alpha level to 0.05, we would fail to reject the null hypothesis and conclude that for chocolate relative to vanilla, the regression coefficient for video has not been found to be statistically different from 0, given puzzle and female are in the model. For chocolate relative to vanilla, the Wald test statistic for the predicted puzzle is 3.978 with an associated p-value of 0.046. If we again set our alpha level to 0.05, we would reject the null hypothesis and we will conclude that the regression coefficient for puzzle score has been found to be statistically different from 0 for chocolate relative to vanilla, given that video and female are in the model. Similarly, for chocolate relative to vanilla, the Wald test statistic for predictor female is 4.362 with an associated p-value of 0.037. This p-value is also significant, and if we set our alpha level to 0.05, in this case we would reject the null hypothesis and conclude that the difference between male and female has been found to be statistically significant for chocolate relative to vanilla, given that video and female are in the model. For chocolate relative to vanilla, the Wald test statistic for the intercept is 2.878 with an associated p-value of 0.09. With n alpha level of 0.05, we would fail to reject the null hypothesis and we will conclude A, that the multinomial logic for the males and with 0 video and puzzle score in the chocolate relative to vanilla are found not to be statistically different from 0. And B, for males with 0 video and puzzle score, you are statistically uncertain whether they are more likely to be classified as chocolate or vanilla. We can make the second interpretation when we view the intercept as a specified covariate profile. Based on the direction and significance of the coefficient, the intercept indicates whether the profile would have a greater propensity to be classified in one level of the outcome variable than the other level. Now this is the case for strawberry relative to vanilla, and we can also interpret these results just like I interpreted for chocolate relative to vanilla. I would come to exponentiated beta here. And what are exponentiated beta? These are very important. These are the odds ratios for the predictors, for the independent variables, and they are exponentiation of the coefficient. That is, the coefficient is raised to the power of the exponent e. There is no odd ratio for the variable ice cream because ice cream as a variable with 2 degrees of freedom was not entered into the logistic regression equation. The odd ratios of a coefficient indicates how the risk of the outcome falling in the comparison group compared to the risk of outcome falling in the inference group changes with the variable in the question. If the odd ratio is greater than 1, then it indicates that the risk of the outcome falling in the comparison group relative to the risk of outcome falling in the reference group increases as the variable increases. So it means that if the odd ratio is greater than 1, then there is a positive relationship between the coefficient of the variable and its likelihood or the probability. So now coming to the second category, if the odds ratio is less than 1, then it indicates that the risk of the outcome falling in the comparison group relative to the risk of the outcome falling in the reference group decreases as the variable increases. Now see the interpretations of the relative risk ratios below for example. Now let me go to another slide, and here is the analysis of the chocolate relative to vanilla, and these coefficients of videos, puzzle, female, and then the Wald statistics are interpreted in the way I just discussed before. So I leave this for you, and the interpretation is there, the whole detail is given here. And finally, there are the 95% confidence interval for exponentiated beta. This is the confidence interval CI for an individual multinomial odds ratio given the other predictors are in the model for outcome M relative to the reference group. For a given predictor with a level of 95% confidence, we would say that we are 95% confident that the true population multinomial odds ratio lies between the lower and upper limit of the interval for outcome M relative to the reference group. It is calculated as the exponentiated beta with z alpha 2 times standard error, where z alpha by 2 is a critical value on the standard normal distribution. This confidence interval is equivalent to the z-test statistic. If the confidence interval includes 1, we would fail to reject the null hypothesis that a particular regression coefficient is 0 given the other predictors are in the model. An advantage of CIE is that it is illustrative. It provides a range where the true odds ratio may lie. Ladies and gentlemen, this is a interpretation of multinomial logistic regression model. Now I would like to show how can we run multinomial regression model. Now this is that data for which I showed the output in my presentation, and if you see, the first variable is the ID, that is the ID of the respondent, or you can say the subject, that is the ID of the student, and this is the gender variable, and this is the ice cream 1 2 3. There are 3 categories. These are scores on video test and these are scores on puzzle test, and this data starts from observation 1 till 200, because I told you that there are a total of 200 students in this analysis. You can see here that the total number of students involved in this analysis are 200. And if you go to variable view, these are the description of the values. Now for female, as I told you, 0 stands for male and 1 stands for female. Similarly, for the 3 chocolate flavors, 1 stands for chocolate, 2 stands for vanilla, that is the base category, and 3 stands for strawberry. And there are 2 other independent variables. One is video and this is numeric, and this is scale variable. Similarly, the puzzle, which is test score on puzzle, that is also a numeric and it is a scale variable. Now let me show how can we run multinomial regression model. Now let me go to the top of this data. I'll go to analyze, and after that I will go to regression, and here there are many choices. I would since my aim is to perform multiple logistic regression analysis, so I will click on this, and here I have already put my data in the independent variable. My independent variable is the preferred flavor of chocolate. So there are 3 categories, and 1 2 3, and the reference category, as I told you, I have customized as 2, and 2 stands for vanilla. So chocolate to vanilla and then strawberry to vanilla is relatively explained here. And just remember, if you have a categorical independent variable, then that variable should be here, and if the independent variable are scale variables, then they should be scoot here. Now if I press OK, here is my output. This output is exactly the same that I just interpreted in my slides. So these are the frequencies of the chocolates: 47 and 23.5%, frequencies 95 and its percentage is 47.5%. For strawberry, the number of students preferring strawberry is 58, and its excuse me, relevant percentage is 29%. Similarly, out of 200, 109 are female and 91 are male students, and the total number of student is 200. Again, this is that subpopulation, and this is 117 that I explained earlier. These are the likelihood of the intercept only and the final model only, and these are the three pseudo R squared. And if I scroll it down, here are the parameter estimates that I just explained, and these are the coefficients for chocolate relative to vanilla, and these are the coefficients for strawberry relative to vanilla. Ladies and gentlemen, although it's a little bit complicated, but it is not impossible to understand and comprehend it. Watch this video. If you cannot understand on the first watch it again, watch it again. If you watch it a number of times, you will easily understand how we run the regression and how we interpret the results of the multinomial regression model. And if you still don't understand, do ask. Write your comments below the video, and you can ask me by email, and I will try to answer your question. Ladies and gentlemen, kindly do subscribe to the channel, and if you haven't yet subscribed, do subscribe. Share this video with your friends, colleagues, and so that the benefits of these information can reach to a maximum number of people. Thank you and have a good night.